And my favorite student, good old Ann. This quiz was mostly plug and chug. Number one says how much work is done. I visualized the car and I said, okay, the distance is moving in that direction. The kids are pushing in that direction. Ben, are the force and the distance in the same direction? Say yes. So I can use my work equals force times distance equation. It's going to be 767 times 28. I said, okay, 767 times 28. I got 2146. I rounded that to 21,500 joules, but I kept that on my calculator. Half mark for the number, half mark for the units. Suppose they complete this task in 58 seconds. What's the power? Power is work over time. It's going to be, I'm using my answer button, not 21,500 divided by 58. No idea what the answer is. 370 units. Power is measured in watt. Power is measured in watt. Watts. I see a couple of you writing like mad as though you're copying. Don't do that. Try the quiz on your own if you didn't do the quiz. You'll have to try it yourself and then mark it yourself and then hand it in. Number two, key idea here, raising or lifting. The work done is mgh. In fact, what we're going to say today is when you lift something, you're giving it potential energy. That's why gravitational potential energy is mgh. You're doing work against gravity. So it's going to be 688 times 9.8 times 2.8. 688 times 9.8 times 2.8, you're doing 18,878 point. You know what? I'm going to go 18,900 joules of work. Suppose it does this in 73 seconds. Power is work over time. Now, power is also force times speed. Let me pause the video for a latecomer. So, it's going to be, I'm going to write 18,900, but you know I'm using my answer button divided by time. It's going to be answer button divided by 73. And I get 258.6. I'm going to call it 259 powers measured in watts. Work a vector or a scalar. It's a scalar. Work is measured in what units? You could say joules. I mean, a joule is technically a Newton meter because it's force times distance. And in fact, you could even take it further than that since F equals what? F equals what? It's technically a kilogram meter per second squared meter, which, you know what, you could probably write like, it's technically kilogram meter squared per second squared. Nobody writes that. But if you wanted to go all the way down to the guts of that unit, Owen, that's what it is. We all just write joules, and I'm guessing that's what all of you wrote as well. Power is measured in what units? Well, it's work over time. It's a joule per second, but we said this was a watt. And if I wanted to, I could dive it. Well, I could put a kilogram meters per second, meters squared per second squared there. I'm not going to bother. What is the minimum power? Okay, power, well, that's work over time. How did I know work over time and not force times speed? Because they gave me a time. So how much work? Well, climbing, that's like lifting your body. You know what? That's going to be mgh. So it's going to be mgh over time. What's the mass? 64. What's g? 9.8. What's the height? Well, it's 82 stairs, and each one is 0.21 meters. I had to do a conversion. Divided by 83 seconds. That's how much power. 64 times 9.8 times 82 times 0.21 divided by 83. Did I type that right, Mr. Dueck? I got 130.1. I'll just write 130 watts. Next page. What's the power output of a motor? Again, the trigger word here to me, Seda, was lifts. That means the work is going to be MGH. So I said, this is really just like the question I did. Power equals work over time. It's going to be MGH over time. It's going to be 25 times 9.8 times 24 divided by 32. Be 25 times 9.8 times 24 divided by 32. And I got 183.75. I wrote 174. Power is measured in watts. We skipped B. This one I had a couple of students asking me about. I lifted this right from the lesson. So how much work did the applied force do? The work done by the applied force is going to be the applied force times distance. What's the applied force? 65. They even use the word applied. What's the distance? Not 12, Mr. Dueck, 14. How much work did the applied force do? 65 times 14. 910 joules of work. However, some of that work went into friction, overcoming friction. So it wants the work done by friction. That's going to be the force of friction times distance. I should do a free body diagram here, but Liam, I'm trying to get through this as fast as I can to give you lots of time to work on the homework. So I'm just going to say to myself, friction is what times what? Mu times the... It's on your formula sheet, which you have out in front of you. Friction is what times what, everybody? Mu times the? For you? Okay. Quick like a bunny. Yeah, it's going to be mu times the normal force times distance. In my free body diagram, Aiden, I would say, I don't know the normal force. Oh, but look, I think it's the same size as mg. I think in this case, the work done by friction is mu times m times g times d. If I run the numbers, it's going to be, what's mu? I don't know, what's mu with you? 0.25. M was 12 times 9.8 times 14. 0.25 times 12 times 9.8 times 14. And I get 411.6. You could write 412, except it's negative. Why is it negative? Because in this case, the force and the distance are in opposite directions. What's the net work done? The net work done is going to be how much was put in, 910, Mr. Dueck, minus 411.6. The net work done is 498.4. All right, 498 joules. That, my friends, was the quiz. If you can give yourself a score, not out of 13 this time, but out of 12, that would be lovely. Any lawyering with me? Now is the time.